Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. You are welcomed once again, and we will continue as usual. First of all, I would like to give the brief summary of the previous lecture. If you remember, in the last lecture we discovered, or you can say we studied, a very different phenomena as compared to our previous discussion. What was the difference? Although it was a kind of regression, but one major difference was that our dependent variable became that was you can say the qualitative response variable. So such kind of variables are called qualitative response variable, in which the dependent variable has categories, or you can say there is no ratio scale variable. So what was the we discussed that if this is the situation, in the whole discussion we were totally unaware of what is happening on the independent side, because we just concentrated on the dependent variable, and this was the issue, because our dependent variable is always much sensitive. We said that if this is the situation, if we run the OLS regression, although we will be able to estimate our parameter, but the possibility is that it may suffer some of the statistical problem. It immediately gestured that we should go for some other technique that could overcome this problem. So the first technique as an alternate to, you can say, the OLS was the linear probability model. In the linear probability model, the model assumed that the probabilities of owning a house, if you remember the previous example, that the probability of occurring an event was 1, and if it doesn't occur, the probabilities was 0. So on the dependent side there was 0 and 1, and we continued over this, and we came to know that this model is still biased and it has some of the problem. For example, the first problem we faced, that the heteroscedastic variance, that is the basic and fundamental assumption of the linear classical linear regression model. Then there was another, that it is not necessarily that we estimate the values of the estimated are not above than 1 or less than 0. So it could cross the limits of this. That's why we made a question that we need such kind of model or such kind of technique that could ensure that the probabilities will remain within the limits. So the immediate candidate for this was the Logit and the Probit model. Logit and Probit model are very similar to each other. The only difference between these two techniques is that the logistic model is based on the cumulative density function, and it is logistic cumulative density function. As compare or as contrast, the Probit model is based on normal cumulative distribution function. So this was, and the Logit model has, rather than using the direct probabilities, it uses the log of the odd ratios. What was the odd ratios? It was the probability of the occurrence of an event with the ratio to the probability of not occurring the event. After these two, we see that there is only one difference, as I explained, and there was another difference, that the logistic model approaches the extreme values in a slowly way as compared to the Probit model. So when there is a question that how to decide that whether a researcher should use the Logit or the Probit model, there is no rule of thumb, and we simply say that the both can solve the problem, or both can do the required estimation, but only the mathematics in logistic is a bit easier. That's why the researcher prefer this over time. After this, we studied that the ordinal Logit and Probit model. What was this? In up to here, LPM, linear probability model, and the logistic and the Probit model, they assume that our dependent variable only a categorical variable, and it is bicotomous, not trichotomous, not polycotomous, and you know what is bicotomous and so on. So when there is a situation that the dependent variable has more than two categories, then we use the ordinal Logit and the ordinal Probit. All other assumptions remain the same. After this, if you remember, we studied the multi-logit and the multi-probit model. In the previous that I have just explained that the ordinal logit and probit, here we say the categories of the dependent variables are rankable. We can rank which is lower, which is higher, and so on. For example, if you are given the questionnaire that whether you like the bananas, there is do not like, strongly like, and whatsoever. These are rankable. But if such kind of situation is that these categories are more than 2 and these are not rankable, then we have to go for the multi-logit and multi-probit model. And how can we give the example of this? We can say that in this situation, the option is that, for example, I ask by which how do you reach your college? You may say that on your bike, car, train, bus, whatsoever. But at the same time, I can't rank this, that which is better and which is not better. So in situation, multi-logit and multi-probit are useful. What we are going to do today, if you remember, we will do a very small, spend a very small time duration models. These are also used nowadays. It is, you can say, the connectivity of the previous lecture and where we closed that multinomial and multinomial logit and probit model. I will just spend a very small time on duration of models, and then ultimately we will go into another regime, and again very important. I think now you are very familiar with the word of important, in which context I use. Each and every point of every course is important in different circumstances. So we will be talking about that what is the panel data, and we will also discuss that how to estimate what's the problem are, what are its benefit, and doing some of the example. So starting from the duration model. If you see, if you look at such kind of thing, that what determine the duration of unemployment spell. There are unemployment spells in the economy nowadays, you can assume, but it is the reality that there is a very severe unemployment spell in our economy. There are unemployment is very high. So if you ask that how will take a time that this spell will remain, we are simply saying, you are asking that what is the duration of this spell. For this, what you will be doing this, you will be using the duration model that has the potential capability and ability to give answer of such question. The second question may be, what determines the life of a light bulb? When the factories manufacture these kind of things, I have just given example of light bulb, there may be refrigerator, radios, and whatsoever, everything could be there. But what situation could be that if how longer life this light bulb will be, the duration models help in solving such a phenomena. The other example may be that what factor determine the duration of a strike. In Pakistan there are nowadays strikes. Tahirul Qadri came and there was a strike, and many a dharna or strikes, what kind of thing. If when there was a dharna of Dr. Tahirul Qadri in the Bilu area of Islamabad, if someone would ask the government was interested in how much time these people will stay here. So the duration model is equally important for all the people, all the researcher, all the policy makers. And the last but not the least, I can say, what determines the survival time of a HIV positive patient. Most of the time it is said that HIV patients, they are just going towards the, you can say, the cruel clause of the death. So how if a doctor examines a person who has positive HIV, How he can say that how many days or years or month this person can survive? This is possible with some of the margin. They are not 100% sure about this, but most of the time, being on experience, on the calculation, on the estimation, on the procedure, they are in a position that they can tell that how many days it will survive this person. These models are also known as survival analysis or time event data analysis model. As they are related to time and you can say the duration, these are called the duration model. In each, what is one thing important is that in each of the examples of the key variable is the length of time. Now time has become extraordinarily important, although in real life time is also extraordinarily important, but in this situation now time has become a variable, and or you can say the spell length, which is modeled as a random variable. Now the time as not a systematic time, the in duration model, these are taken as a random variable. So this was the story about some of the models when there is such kind of situation. Now our discussion about such kind of model, linear probability model, logit, probit, tobit, ordinal logit, ordinal probit, multinomial logit and multinomial probit comes to an end, and now we are going to enter into another area that is equally, you can say, important as well as the interesting area. Panel data regression model. So first of all, we should see that what is the panel. I am 100% sure that from the very first lecture you are aware of this phenomena. So as I know that your memory is, it is necessary to refresh and ignite your memory, I would like to give you that what is the panel data. If you remember, we talked about some kind of data. These were the time series data. The data on variable over time is cross-sectional. The number of time unit is only 1, but the number of objective is greater than 1. And the panel data is also called the pooled time series data or whatsoever pooled data. Panel data combines the cross-sectional and the time series data. So in other words, what we can say that it has the information at one hand from the time series data, and it has also all the qualities of the cross-sectional data. When there is a mixture, hybrid of this, it becomes a panel data. Panel data have space as well as time dimension. The other variables are time series data has only time dimension, have no space dimension. Similarly, the cross-sectional data has space dimension, but it has not time dimension because the time unit is only 1 there. But in pooled data or in panel data, you can see that it has both the dimension. It has the time series time dimension as well as the space dimension, and from right now I think you are in a position that this is a more important data as compared to the time series and the cross-sectional data. Again, I would like to clear that when I say that this is important, it doesn't preclude that the other are less important. The only difference is that they, in comparison, we can say that this is an improvement over the previous, because when there are both the time and the cross space dimension, definitely that hybrid may have some extraordinary benefits that we can see at any stage. There are other names for this data. These are the pooled data, as I said, because you are pooling the time series and the cross-sectional units. And it is combination of time series and cross-sectional data. It is also called the micro panel data. So whatever the name is present there, the meaning is the same. The label is different, but within the label or within the bottle is the same thing, that is the panel data. Panel data are nowadays being used extensively in all the researchers. Most of the time a researcher try to get the panel data because it gives more information, need not to explain. Why panel data? That when we have the time series data and we have cross-sectional data, then what force us that we combine the data? So what is this? Since panel data relate to individual firm, states, countries, now these are the cross-sectional units, over time there is bound to be heterogeneity in these units. So first thing is that as you will be using for this purpose, you will be pooling, you will be bringing into the net different types of population, and there is maybe heterogeneity, so the comparison becomes possible, and you can say the easier. For example, if all the people, all the population are similar, then the comparison becomes a bit difficult. But as the units are heterogeneous, then the comparability becomes a good thing. The technique of panel estimation can take such heterogeneity explicitly into account by allowing for individual specific variable. As I said, that when there will be heterogeneity, Pakistan will be different from Sweden, Sweden will be much different from Nigeria. If there is heterogeneity, the panel data estimation techniques already are built on in such a way that they explicitly take care of this phenomena. As you know, we say that there should be no heteroscedasticity. If such kind of thing is there, no need to worry. The panel data estimations that we are just going to continue discussion, we will come to know that these are explicit. This word is very, you can say, the important, that these techniques know that there is heterogeneity in the data, and they have already, you can say, taken care of this. By combining time series and cross-sectional observation, panel data give more information on data, more variability. If you remember that if you want to see the average behavior of your dependent variable, that is your ultimate objective, keep in mind that your independent variable should have much variation. For example, if you want to see that what is the consumption behavior of a college people, the faculty of a college. So if you go to the college, if you just study the behavior of the lecturer, there will be not difference in their income, because all the lecturers with small varying degree, they are earning the same income. But if you start from the lower staff, the clerical staff, the lecturer, assistant professor, associate professor, then you will come to know that your data will have some of the variation. So this is as you combine the cross-sectional as well as the time series unit, the data, panel data, the pool data or the micro panel data provides more variation among variables and more degrees of freedom and more efficiency. These are, you can say, the benefit of this. These are benefits of this of using panel data. Why panel data discussion continues? By studying the repeated cross-section of observation, panel data are better suited to study dynamics of change. So this is now important, the dynamics of change. As we are interested, we say that if there is one unit change in independent variable, on average such and such. So if we study the cross-sectional observation, panel data are in a better position to give the dynamics of change. How the changes are being done, because at one side the cross-sectional units are present and on the other side time series units are available. The fourth reason that why we use the panel data or study the panel data can better detect and measure effects that simply cannot be observed in pure cross-sectional or pure time series data. This is very strong quality and the characteristic, or you can say the salient feature of the panel data. What this is? That it has the potential to measure those effects. It means it can bring some hidden things out of there. It brings information out of this that are impossible for the only cross-sectional data or separately the time series data. So this has, you can say, the powerful tool, and it can even detect the variation that are not possible, that if you are using only time series or if you are using only the cross-sectional data. The fifth one is the panel data enable us to study more complicated behavior model. Time series analysis are simple, cross-sectional are simple. But for both of them are different techniques. There is time series quantitative techniques, there are time series cross-sectional quantitative techniques. But if the matter becomes more complicated, then the panel data is necessary. And you know, as there is refinement and as there are multidisciplinary and everything is now linked with each other, the phenomena of studying a behavior of a thing or object becomes critically important. So what we do? In this case, there is a good, you can say, the help from the panel data. And the last thing in this, I can say that making data available for several thousand units. Definitely, when you will be pooling data, your number of observation will increase. Panel data can minimize the bias that might result if we aggregate individual or firms into broad aggregates. So this is, in other way, very simply I can say that this is an increase or enlargement of the data. If you separately aggregate the individual terms, it is not as beneficial as here you can see the panel data. So these were some of the characteristic or salient feature of using the panel data. So panel data can be defended on a very strong ground, that why a person or researcher like you are using the panel data. So it is, you can say indirectly I am suggesting that if you have the opportunity to use such kind of data, this is much better as compared to the other data time series and the cross-sectional. They have their own importance in their relevant context, but it is a hybrid and the combination of the two, and it can bring more information and it can solve the complicated and it can show the complicated behavior of the people or the phenomena. Panel data example, we build our panel data estimation. As you know, to do estimation here is not possible. I have just brought some of the, you can say, the regression results, and my purpose is to tell you that what is the meaning, the interpretation, the implication of this. So before going further, first we have to set the ground and then we will build our analysis on this. How real gross investment? So it means our dependent variable is y, and that is a real gross investment. You should remember in the during this lecture I may ask you and you will have to answer this. You will be laughing how you can answer, but I will keep on refreshing your memory. And this real gross investment, or you can simply say the investment, depends on the value of the firm and real capital stock. So there are two independent variable and one dependent variable. So if I would like to this one, so this is y is equal to beta 1 plus beta 2 x2 plus beta 3 x3 plus ut. This is as usual. So what is the yt? Yt means now rather than I should write now yit. I now for cross-sectional, T for time. Look at this, we came to know, otherwise we may have gone without this. I is the indicator, I will be telling in the same slide. I is the indicator for the cross-sectional for one unit, 2 unit and 3. And the T is the, you can say, the indicator of the time from starting from 1 year to up to your data. This is x2 is this is yit, and y is the real gross investment. Real gross investment. And you can see that the x2 is value of the firm. You are project manager and you know what is the value of the firm, because you make the project about this and that. and this is, thus you can say, these are the real capital stock. Real, do you know what is capital and what is capital stock? I think it is not necessary to explain. So I have set this model that our dependent variable, you should remember this, because in the next slides we need not to come back again, and we will be concentrating on the only one thing is important, that I have included IT, and I should include these IT with all the variables. Now this is 2IT, X3 IT. I is for the ith cross-sectional unit and T is from the time units. Data on 4 companies. There are 4 companies, and as I am following some of the, you can say, the books, so there are 4 companies, and what are the 4 companies? The first is the General Electric. So GE means General Electric. The GM means not the general manager like you, but this is the General Motor. And there is US only. US means not the United States, but we will see it that it is a factory or mill in United States. And Westinghouse, we will only, you can say, for our simplicity, we can write it as only the West. So there are 4 categories. We have a 3 variable regression model, 1 dependent, 2 independent variable, dependent variable you know, and independent you also know. Data for each company on 3 variables. Now you know the variable Y, X2 and X3. Data for each company variable are available from period 1935 to 1954. Now guess how many years? I can say that these are 20 years. Data available for each firm. 4 firms, data for available for 20 years. So what this means, I is here, kitna hai ji I? Cross-sectional unit? 4. There are 4 firms. And let me know the General Electric, General Motors, what was the other? US Steel, and the other was the Westinghouse. These are the 4 cross-sectional unit, and T is from 1 to 20 for each of the firm, and this is, you can say, from 1934 to 1935 to 1954, and it is 20 observation. This is the setting of the ground. Thus there are 4 cross-sectional units and 20 time series units. In principle, we could run 4 time series regression, 1 for each company. On the basis of our previous literature and experience, it is very simple to run the OLS regression. What this means, take the observation of each company separately. हर कंपनी की आपके पास 20 observation आ गई. For example, let me give the data. For example, I say that this is Y, this is X2, this is X3, and I can say that this is data for General Motors. I am just assuming. These are 20 observation. We have the data from 1935 to 1954. Same data, 20 observation here, 20 observation. Simply we can run the OLS regression. So what we'll be doing this, rather than combining the cross-sectional and the time series unit, what we are doing, we are becoming very smart and we are making the OLS regression on each and every separate unit. So now we will see that is this okay, or we have to see for something. And the other is we could run 20 cross-sectional regression, 1 for each year, vice versa. वहाँ पर क्या था कि 4 यूनिट 20 साल का डाटा, you can run the regression, 4 regression. Here 20 years data for 4 firms. In 1 year you have 4 observation for each firm. In the second year 4 observation. So what this means, you can run 20 time, you can say 20 cross-sectional regression, 1 for each year. Although in the later case we will have to worry about the degree of freedom. In the first case, no problem. 4 objective, 20 observation, run the OLS regression. But here you will see that there are 4 cross-sectional unit, and there are and you are running the 20 cross-sectional regression. The problem of you can say the degree of freedom is making some of the problem here. Now, how to estimate this panel data? Definitely now you have come to know that what is the panel data. The first candidate is, rather than the OLS, the first is the fixed effect approach. I will be calling from right now, I will be calling it FEM, fixed effect model. I will be so whenever I write FEM, it means it is the fixed effect model. So to study that, now we are disregarding the OLS. What the OLS can do, that we can use the OLS, but still it will definitely, as I said, either you can do the cross-sectional, or you can do the time series or cross-sectional. Consider the model. Look at this model. Now you can see here are the YIT, beta 1, this one, and I is from 1 to 4. You know there are your 4 cross-sectional units, and T is from 1 to 20, and you know the time period for this is 1935 to 1954, 20 observation. Now look at this. It will, for remember you, I stand for the ith cross-sectional unit. I1 means General Electric, I2 means General Motors, I3 means United States Steel, and I4 means the Westinghouse. Again, keep in mind that this is my arrangement. It is not some sacred arrangement that you should always go in this way. You can say that I1 is the Westinghouse, so it never affect your model, as we saw in the case of dummy variable. You will come to know interestingly that this at the end I will be calling it that it is also indirectly the least square dummy variable technique. So and T stands for the T time period. If T is, I say 20, it means this is the last observation in the time series. As a matter of convention, we will let I denote the cross-sectional identifier and T the time identifier. It is convention. It is not again sacred, or you can say the fast and rule to always use IT. You can use some other notation, but sometimes there is some standard notation. So following that, I am doing this. If each cross-sectional unit has the same number of time series observation, then such a panel data is called a balanced panel data. Panel data has two kinds. This is, I think I know, I explained panel data. This is the balanced panel data, and this is the unbalanced. If you look at this, this is the balanced data, because for all the firms, General Motors, General Electric, Westinghouse, and United States Steel, the number of time unit is 20. So this is the balanced data. But if I suppose that I have data for General Motors only for 10 years from 1935 to 1944, it is only for 10 years, and for other, the situation is the previous one, that for other the data is available from 1935 to 1954. So if this is the situation, this falls into the category of unbalanced data. So there are different techniques for unbalanced data, but our concern is totally on the balanced data, and we will be studying that. What is this? Fixed effect model. Now you can see that I have written the FEM here. Estimation of the model depends on the assumption we make about the intercept, the slope coefficient, and the error term. Now error terms, slope coefficients, and intercept have changed their interpretation, because now you have combined two series, that is the cross-sectional and the time series. So now we will have to make some of the assumption about the intercept, the slope coefficients, and the, you can say, the UI if I go back to this slide, look at this. This is the intercept. I will have to make assumption. I will tell you what assumption I can make. The second is these are the slope coefficient beta 2 and beta 3, and I have to make ut because it is not the as ut that is either in the cross sectional or in the time series. Now it is a uit, that is a combination of ith and you can say the t series. First is the assume that the intercept and slope coefficient are constant. This is the first, you can say, the assumption. Our assumption is across time and space. क्या जी हमने बड़ी hard restriction लगा दी जी मॉडल पे that the intercept and slope coefficients are constant. In which side, in which dimension they are constant? They are constant across time and space. What we are saying that we will not allow the intercept term to change either in the cross-sectional dimension or the time series, and the error term captures differences over time and individual. Definitely up to here, when we are restricting our model, the sudden question comes that how the difference will be captured. We are taking one more assumption, and assumption is that the error term captures the differences over time and individual. That we have restricted in our first part of our assumption. The second is that the slope coefficients are constant. पहली में दोनों को हमने रगड़ दिया. We said no, they can't change. In the second, we are just lapsing. We are becoming some kind-hearted, and we are saying some of the flexibility. We are injecting flexibility into our model. So what this we say that the slope coefficient are constant. इन पे अभी भी सख्ती है, but the intercept varies over individual. Rather than going here, I would like to again tell this that when we are assuming that neither intercept change nor slope coefficient change across time and space, then who captures the difference between the time and difference of the forms over time and space? Then we say that the error terms has the potential. It is our assumption that error term is now performing this duty and it is capturing the difference. The second is that slope coefficients are constant, but the intercept varies. Intercept is, again, if you remember, this was the beta 1. That is without the variable. So now we are allowing beta 1 to change, but we are putting the strict hammer on the coefficient. We say we not allow them to change. Varies over individual. इसको भी हमने थोड़ी सी रियायत दी है that this intercept can change only across cross unit. We have never allowed it that it can cross over the time series. So this could be the second situation. The third is that the slope coefficient are constant. The similar up to here it is similar, but the intercept varies over individuals and time. We are more relaxing towards the intercept. In the first category, in the second, we said that intercept varies but only across units. But now we are giving more, we are becoming more and more generous, and we can say that this it can change, be changed on you can say the time as well as on the space and time. The fourth could be the all coefficients. You are becoming very kind-hearted. आज मौसम लगता है बड़ा सुहाना है. That's why you are giving more and more relaxation to your model. So what this means, all coefficient, the intercept as well as the slope coefficients vary over individuals. अभी भी आपने कुछ restriction लगा रखी हैं because vary over individual. What is this? But now you have become very flexible, and you should be flexible to capture more and more information in your true life, or you can say the regular life. The man or the man mean human being should be flexible. We should have some of the negotiation. It brings more maturity into your personality and thing. If you are so strict, the people may not gather around you. All coefficients, this was some of philosophical discussion. You can go on your own way. It was just my guess, observation. All coefficients, what is the fourth possibility? That the all coefficients including intercept and the you can say the slope coefficient, they can vary over individual. And the fifth is the intercept as well as the slope coefficient vary over individuals and time. Maximum relaxation, that you can set that all the your coefficients beta 1, beta 2, beta 3, they can not only change across cross-section unit, but they can change over time. So what was this? Why we are explaining this? Because every time we will have to modify our model. It is not like OLS that every time you are doing this one, but every time in each possibility we will be just changing our model only notation. For example, if I say that the intercept is changing, I should show in the model that how a person come to know by looking immediately at my model that the intercept is changing, and so on. The first now there were, if you remember, there were the 5 categories. Now we will be discussing all these categories one by one, and you will enjoy the whole discussion because it is now has become very relevant to you, and you have now the base that there are 3 variables. What are the variables? I think you know. Y is the real investment, X2 is the value of the firm, and X3 is the capital stock. And there are, what is the time length of the data? For each firm, data is available from 1935 to 1954. For each firm, you have 20 time series observation. The simplest model, look at this, I am using the word simplest, and the possibly naive approach is to disregard the space and time dimension of the pool data and just estimate the usual OLS. When we are saying that all coefficients are constant across time and individual, so what this means, we can run the OLS regression. How we can run? We take the 20 observation for each company, one on the top of the other, thus giving in all 80 observation for each of the variable in the model. The OLS results are given. आप OLS से इधर उधर हटते ही नहीं हैं. Look at here that I would like to write here. Look at this. Now what we are doing, we are taking first the General Electric 20 observation उसकी रख ली, उसके नीचे 20 observation आ गई General Electric मोटर की, 20 observation जो है again for United States Steel, and again 20 observation for the last, that is the Westinghouse. So now in one line you have 80 time series values for each variable. So if I would like to this one, this will become, this is YI, YIT. Now you should understand YIT, X2 and X3. Look at this. For example, from here to here I say that this is for the General Electric. So for General Electric there are 20 observation up to here, 20 for Y, 20 for X2 and 20 for 3. From here the other starts, that is the General Motor. Similarly 20 observation here, 20 for Y1 and X2 and X3. Similarly the next is the US Steel, same observation, 20 observation for this, and similarly for the last one. So if I will add up all the observation, there will be 80 observation. So what we did, we disregard each and everything. We did not take care of that. Is there any difference? Why we did this? Because we are assuming that all the coefficients are constants across time and individual. Beta 1 is not changing, beta 2 is not changing, beta 3 is not changing. So if this is the situation, we are putting huge and many restrictions on the model, and if we do this, we set the data in this way, we run the OLS regression. These are regression results before you. Now look at this, that what is that? Look at this, this is the beta 1 intercept, beta 2, and this is the beta 3. Now I am not going to interpret this, that what is this and what is not. I am going to see that whether the result are significant or not. Look at the standard error. This is. Our more interest is in the t values, because from here we can see that whether the parameter is statistically significant or not. If you look at this, here is minus 2.13. As the t statistics go beyond 2, we say that the model has, the estimator has become significant. Here is, it is highly significant, here is highly significant. It means the model was correct. R square, it is a good measure, and it is 75%. We are satisfied that our model is explaining 75% of, you can say, the variation in the dependent variable. But one thing is, what is this? NR observation are 80 and degree of freedom are 77, because we are estimating there are 4 forms, and we are this is n minus k, and it is equal to 77. So what this means, if you look at the model, this is one parameter, this is second, this is 3 are the k, n minus k is equal to 77. So what is this? One thing, or you can say the bone of contention or fly in the ointment, रंग में जो भंग डाल रहा है, that is the Durbin-Watson statistics. कितनी होनी चाहिए जी? याद है कोई आपको? I think you remember that the Durbin-Watson statistics should be very near to 2, because what is this measure? This is measure of autocorrelation. Are you agree? Definitely you are agree, because you are learning this. I assume, I am sure that you are keeping, you can step by step with me. Matter is done. One problem is there, that the Durbin-Watson statistics is showing the red indicator that there is something wrong. So what is this? The only fly in ointment is the estimated d-static quite low. What this suggesting that perhaps there is autocorrelation. Everything is okay there, but this is giving of the red indicator that there may be the problem of autocorrelation. So what we will do, of course this could be due to the specification error. आपने जो सब एक दूसरे के नीचे रख के जो है वो OLS लगा दिया, this is showing that there may be the problem of specification bias, because what we are saying, all coefficient constant across time and individual, and there is no change for this. For instance, what could be the, you can say, the specification bias? The estimated model assumed that the intercept value of GE, GM, US and Westinghouse are the same. What we are saying, that there is no difference between the companies. The General Motor is much different from General Electric, United States. But what we are doing something blindly, and we are saying that there is no difference in the intercept. What we say, not over, neither it is difference over time or neither it is across. It also assumes that the slope coefficients of the two x variables are identical for all the forms, if they are same. So what this means, obviously these are highly restricted assumption. OLS to चला लिया आपने, you run the OLS regression, but these assumptions are very difficult for me and as well as you to digest, because these are, you can say, very critical assumptions. So if these are critical assumptions, you will have to give some flexibility. Now what is the flexibility? Slope coefficient constant, go back, this the second portion, that the here was the all coefficient, now you are bifurcating all coefficient into intercept and the slope coefficient, and what you are saying that the slope coefficient constant, beta to आपका constant रहेगा, but the intercept value, the slope coefficients that are attached with the x2 and x3, they are constant, but the intercept varies across individual. So you are giving one, you can say, the flexibility that your intercept, that is the beta 1, it can change across unit. Across unit kya? You are saying that you are going to allow that if there is variation across the firms that are the General Motor, General Electric, you can say that this is possible in the model. In this way, this model becomes least square dummy variable model. So when we will be allowing for the variation in the cross-sectional unit, we will have to add the dummy variable for this. And when we add the dummy variable, it becomes least square dummy variable technique. So how to introduce these dummy? One way to take into account the individuality. What we are saying now, that we are allowing for the individual effect of the firms to be captured. Of each firm on each cross-sectional unit is to let the intercept vary for each company. Now what we are saying, that as we have become flexible, that we are allowing intercept to change across unit. One is say that we allow the intercept vary for each company, but still assume that the slope coefficients are constant across firm. So this is the situation of the model. Now you will have to see it keenly, that by looking there is no difference. Beta 1, beta 2, x3, it, but one difference, look at smartly, look at here. This is now beta 1i. In the previous example it was beta 1. Now it is beta 1i. I means now you are allowing your beta 1 to change across cross-sectional unit. Notice that we have put the subscript I on the intercept term. Abhi मैंने जो है वो explain किया, that you have put the on the intercept term, and this means that where is I, where is t, it means you are allowing the things to change, if I across unit, if t over time. What this meaning? This suggests that the intercepts of the four firms may be different. Now you are not allowing the difference of the firm over time. You are just saying that the firms are different across space. Now what kind of this different? The difference may be due to special feature of each company. आप difference को allow कर रहे हैं, लेकिन आप over time difference को allow नहीं कर रहे. You are saying that this difference across the companies, it is, you can say, based on the special characteristic of the company, because General Motor, General Electric, US Steel and the Westinghouse are much different companies from each other. So you are allowing for this. And the other may be this, what kind of such as managerial style. There is possible that there is centralized managerial style in the General Motor, in the General Electric, and in the other decentralized. There are many managerial managers, and you are the project managers, and you know that what I am saying at this stage, that when you are allowing for the cross unit, कौन सी हो सकती हैं जी क्रॉस यूनिट आपकी जो है वो खसूसियात, that are managerial style or managerial philosophy. Philosophy mean dealing the employees with some, you can say, a different manner. In literature, this is known as fixed effect model. Fixed effect means you have captured the variation across the unit, so it is called the fixed effect model. From, I think I will never write now fixed effect model, and I think I have written that this is FEM, fixed effect model. The term fixed effect is due to the fact, why we call it the fixed effect model? This is due to the fact that although the intercept may differ across individual, here the four companies. Individual is हमारी मिसाल में कितने? There are four companies. Each individual's intercept does not vary over time, that it is time invariant. वही बात जो है I was saying since beginning of this, you can say, the fixed effect model. Why it is called the fixed effect model? The immediate answer is that if you are allowing to change the intercept across unit, you are capturing that if there is different managerial style, if there is some special characteristic of the firm, but you are not allowing the individual firms change over time कि किसकी टेक्नोलॉजी में क्या चेंज आई, रेवेन्यू कैसे हुए, you are still putting, you can blanket on it and you are not allowing for this. It may be noted that the fixed defect model given assume that the slope coefficients of the regressors do not vary across individuals or over time. हम एक ही तरफ अभी तक लगे रहे, intercept, intercept and intercept. But at the same time, we should have to mention that we are not ignoring the slope coefficient, and we are taking a very, you can say, the solid and the concrete assumption about this. Go to the that the slope coefficients are constant. What this means, they are not only constant across units, but they are constant across time also. How do we really, you can say, the introduce now, you can say that we change the model. We changed here model. If you look at here, it was beta 1i, we allow this to change. But I said that we will be using dummy variables, that there are 4 forms and we are allowing the difference. It means we are using some of the dummy variable. So how we will be introducing dummy variable and capturing the information, I will continue discussion from the previous the next lecture. Now I think it is time to give you the summary, because when I am in the habit that when we start a new phenomena, I become a bit slow, and then when the things are clear and built over time, then we start our journey a bit quicker, and ultimately we complete our you can say the topic. So do you remember in the beginning, and today in the first lecture we started from the duration model. Duration model, it was linked to the previous model that when your response the dependent variable is a categorical variable, it is not a ratio scale variable. You talked about many of the model. I am not going to give any of the name, but my concentration is on the duration model. Duration, sometimes we are interested about what will be the duration of this time. For example, if it is raining, if there are otherwise you can say if there is a severe drought in Pakistan, or you can say the Cholistan of Pakistan. So if I want to see that for how long this dry spell will continue, so we will have to revert towards the duration model. Any kind of phenomena can be studied where the time is involved. For example, if a person is ill, I can see that how many times it will take to recover for this. So these are similarly, these are used in all the disciplines. So in this way, in this model, our time variable becomes random variable. So we built on our discussion on this. The next regime that we are discussing in this lecture and the next lecture, that is, we say that what was that? The panel data. Panel data is simply the combination of cross-sectional and the time series data. The reason was that why we use this panel data. The simple reason was that it has the potential to you can say the portray, or you can say the display the more complex behavior of the phenomena. So it is because it captures the information both from the time series as well as on the cross-sectional, so it has potential to address more complicated and intensive issues. Then we talked about that what is our concern. Our concern is only about that we are talking about the balanced panel data. The other names for panel data are micro panel data, or you can say pool time series, or you can say simply the panel data. Balanced data means the number of the data is available for all the cross-sectional unit for equal time limits. For example, if there are 5% and I have data for their weight for 20 years, for all the people, if I have data for 20 years, it means it is the panel data. There are kinds of cross-sectional data, but we are not interested, not the cross-sectional data. There are techniques and you can say the categories of unbalanced data. The different techniques can be used to use this. So when we are using panel data, we have to avoid the OLS. But if we put a very strong restriction, there are different categories, and we have studied just one or two. I would like to say one or two that what are these. If you remember, we said we do not allow the intercept as well as the slope coefficient to change either across neither across cross-sectional unit nor across time. What this means, we are saying that everything is constant. We are not allowing that. We are not allowing the difference between the cross-sectional and the time series unit. The other was we were lapsing one of the assumption. What was saying? We were saying that the slope coefficient will remain the constant, but we are allowing beta 1, that is the intercept, to change only across, you can say, the cross unit. You are not allowing to change it over time. What could be the change in the different companies over across unit, or you can say the across space, that the environment of the company may be much different from the environment of the other company. For example, in one company, the managerial method, or you can say the managerial model, or you can say the how to run the factory or the mill is much different from other. The philosophy of the, you can say, the model is different from one and other. So you are not allowing to change it over time. Still, we are keeping the constant, the slope coefficient constant, and allowing only our intercept to change only across unit. If we keep all the cross-sectional unit intercept and the cross are the slope coefficient constant over time, what we do, we keep the observation at the 20 observation at the top, 20 below, and for in our example there are 4 companies, so we can write it for, you can say, in this way. There will be 80 observation for each variable. There are 3 variables. The first is Y, X2 and X3. If you remember, Y is the real investment, X2 is the value of the firm, and X3 is the capital stock. So for each variable, now I have 80 observation. I will never allow to change this. I can run the OLS regression. The results were there on your screen, and you came to know that it was very interesting. Everything was okay, but one fly in the ointment was that the Durban statistics was low. What this means? There may be autocorrelation because its value is very high. We will keep our discussion continue about the panel data. So take care, goodbye, and Allah Hafiz.